bodies revolve around the center of mass, you get this large motion of the planet, which you cannot see, but you get this small motion of the star, which you can measure. And there have been something like 500 planets detected by that radial velocity technique. There is now another technique that is being applied, and it has discovered well over 1,000 planetary candidates, and I'm going to tell you about that in some detail later. This is the transit technique, in which you look for planetary systems in which the planet moves right in front of the star as seen by you, the observer, looking through a telescope. And obviously, in many planetary systems, that won't happen. The planet might be going around the star like this, and it will never pass in front of the star. But if it passes right in front of the star, then it actually blocks out some of the starlight, and you can measure that. This is an example measured from the ground with a small telescope, and this is a Jupiter-sized planet moving in front of a star similar to the Sun, and it decreases the amount of light that you see from the star by about 1.5% in this case. I will tell you in a few minutes about a mission called Kepler that uses this technique to search for Earth-sized planets, which produce a much, much smaller drop in the light from a star, and looking particularly for Earth-sized planets in what we call the habitable zone. That is the distance from the star at which liquid water could exist on the surface of the planet, and so the planet could be like Earth and have habitable environments like Earth. And then finally, the fourth area of science that again was coming to maturity in the mid-1990s was our understanding that the raw ingredients for life, sugars, amino acids, nucleic acids, etc., are created in interstellar space, and they are then subject to organic chemistry that occurs both in the gas phase and then occurs on grains when grains of ice and grains of silicate condense in the interstellar medium. Eventually, these grains accrete into solid bodies. Eventually, we see those solid bodies in our solar system in the form of comets and the meteorites that fall to Earth. And we can look at the spectra and samples of those comets. We can also look at the meteorites that fall naturally to Earth. And we see in that data, we see the amino acids, the sugars, the nucleic acids. And so this is how we know that the raw ingredients for life are everywhere in the galaxy and everywhere in virtually every galaxy. So that means that all of these planets, and consider there are 100 billion stars in this galaxy alone, and we think that probably most of those stars have planets around them. That means that there are potentially hundreds of billions of planets, and the raw ingredients for life are distributed among all of those